Good afternoon, everyone. We're just going to wait one more minute because we have a ton more people still logging on for this groundbreaking educational forum that's occurring. So it's 12:01. We're going to wait one more minute and then we will get started promptly right after that. So just bear with us for 60 seconds more. Okay, everyone, we're going to get started. So, good afternoon and welcome. My name is Adrienne Esposito. I'm the Executive Director of Citizens Campaign for the Environment. We appreciate everyone's time in joining us today. We're going to say if you have questions along the way, please put them in the Q&A. At the end, we will have time for Q&A. Some of this presentation might be a little technical. Just write your questions down. We will break this down so that it's understandable and informative for you. I do want to say we're going to start out by saying we have wonderful partners here. In addition to Citizens Campaign for the Environment, we have a group called PEER. It's the Public Employees for Environmental Responsibility. We have LaSalle Research and Consulting Company. And we also have the terrific folks at the Center for Clean Water Technology at Stony Brook University. So we're going to begin today, but I want to tell you this is what you're about to hear is really a groundbreaking, unique study here in America. There have been similar studies across the globe, but not as much in our country. So we will go through the data and then we will go through with you what does it mean? How do you interpret that? So I'm going to start out and introduce Dr. Kyla Bennett. Dr. Kyla Bennett is the Director of Science Policy with PEER, Public Employees for Environmental Responsibility. Dr. Bennett, I'm turning it over to you.
Thank you so much, Adrienne, and thank you all for attending today. I would be remiss if I did not mention that this work that we're presenting to you today is only due to a very generous grant from the Virginia Wellington Cabot Foundation. Next slide, please. So we're going to be talking to you today about PFAS in produce on Long Island. And before we can really talk about what that means and why it's important, I just want to briefly talk about what PFAS are. PFAS is a very large family of chemicals, more than 10,000. Some people think there are millions of them. But the one thing that all of these chemicals have in common is a carbon-fluorine bond. And this bond between these atoms of carbon and fluorine are so strong, it's one of the strongest bonds known in organic chemistry. PFAS are all synthetic, they're all man-made. So wherever you see them, it's because they were made, it's contamination. All PFAS are persistent, which means that because of that really strong bond, they do not readily break down in the environment. Many of the ones that we've studied bioaccumulate in your body, and also those that we've done toxicity studies on have been found to be toxic. We only have toxicity information on a handful of these PFAS, good information on about 40 of them, and remember, there are more than 10,000. There's all sorts of nomenclature regarding PFAS, but the one thing that you're going to hear most often are things about long chain versus short chain PFAS. And that refers to the number of carbons in the backbone of these molecules. These two, PFOA and PFOS, that you can see on the screen, those are both 8 carbon. They're considered long chain PFAS. And those are our legacy PFAS. Those are the ones that we first came out into the world in consumer products, and they are the ones that have been studied the most. PFAS are regulated at both state and federal levels. EPA has, in April of 2024, issued drinking water regulations on 6 PFAS, including PFOA and PFOS. And in that drinking water regulation, they said that there is no safe level of those 2 chemicals. They also regulate another 4, but the current administration is trying to rescind the regulation for those 4. Gen X is a long-chain PFAS that was used as a substitute for PFOA. They thought it was safer. It is not. Next slide, please. So where are PFAS found? They are unfortunately ubiquitous. They're really handy chemicals because they are waterproof, greaseproof, stain-proof. So they've been used for decades in things like nonstick pans and furniture and carpet and water-resistant clothing and paints and adhesives. Things like artificial turf and microwave popcorn bags, and even personal care products. So, because these chemicals are so ubiquitous, they go down our drain. So, when you wash your face, wash your dishes, shampoo, wash your hands, do a laundry, all of the PFAS in those consumer products will go down the drain and into wastewater treatment plants or your septic field. When they go to wastewater treatment plants, they actually do not get treated by the wastewater treatment process, and they come out the other end. Actually, more PFAS come out of a wastewater treatment plant than go in. Next slide, please. So why are we concerned about PFAS? When studies were done on PFOA and PFOS, there's something called the C8 studies that were mandated under a lawsuit that happened in the late 1990s. It was discovered that PFOA and PFOS cause cancer. They can cause testicular cancer and kidney cancer. But these PFAS and others also have numerous health impacts. They cause thyroid disease, increased cholesterol levels, obesity, inflammatory bowel disease, pregnancy loss, preeclampsia in pregnant people, and also developmental effects on children. And one of the more concerning things to me, aside from the cancer, is the fact that if you have high PFAS in your blood, then those high levels can make you immune to vaccines. In other words, when you get a vaccine, it's not going to work as well because of the high PFAS levels. And the three exposure routes of these PFAS are ingestion, dermal absorption, and inhalation. Next slide, please. So why did we embark on this project? Long Island has a little less than 600 farms covering about 31,000 acres. Most people don't think of Long Island as a farming area, but it has a lot of farms and vineyards. Now, one thing I want you to keep in mind throughout this presentation is that this is not a problem that is specific to Long Island. This is a nationwide contamination crisis. We are trying to understand the extent and the sources of contamination so we can talk about appropriate solutions. How do these PFAS get into our food supply? They get in from contaminated water. They get in from contaminated biosolids or sewage sludge, which are put on farms, or fertilizers, pesticides. They can come from a variety of sources. So, but please do keep in mind, again, this is not something that is unique to Long Island. This is a nationwide crisis that EPA needs to tackle, and unfortunately, they are not. So I think now we're going to turn it back to Adrienne so she can send it to the next speaker.
I think I am the next speaker. Okay, so some of you are going to ask, well, is it because of the water? I know you're going to ask that. In order to really be able to understand that, we just want to remind most of you that some of you already know this, but 100% of our drinking water comes from directly underneath our feet. We are classified by the US EPA as a sole source aquifer. That means that we all drink from underground a water supply that is obtained through digging wells, and the wells then supply us with that drinking water. Next slide. We have drinking water standards here in New York State. If you have a municipal water supply, you are drinking water that meets the standards. The standard is 10 ppt or parts per trillion for PFOA and PFOS, the two most common PFAS chemicals. All of our drinking water suppliers right now are meeting or exceeding that standard. The good news about PFAS in drinking water is that we are very readily and easily able to filter it out of our drinking water supply with a standard carbon activated granular filtration system, which water suppliers can get grants for from New York State. Next slide. Okay, we know we have PFAS on Long Island. We just put this in here to illustrate to you. It's all over Long Island. even though we tested farms on the North and South Fork, this is not a farming problem. I'm going to say that later on in a minute, but this is to illustrate to you we have PFAS throughout the drinking water on Long Island, which is why the vast majority of water suppliers have one or more treatment on the wellheads. Next one. Okay, so what did we do? What we did was in the summer of 2025, last year, our staff went to a variety of local farms on the North and South Fork. We went to a total of 8 farms. 2 farms were organic and 6 were conventional, which means that they use pesticides. We specifically targeted 4 different vegetables because in the scientific literature, we know that these root vegetables, as they're called, and also broadleaf vegetables like Boston lettuce and romaine lettuce are known to pick up and absorb PFAS chemicals. Carrots, beets, romaine lettuce, and Boston lettuce are the 4 vegetables that were tested by the Stony Brook Laboratory. I got a question yesterday. Someone called and said, well, maybe it was contaminated when you were picking them up. I said, no. We used very strict protocols. We used specific PFAS-free gloves. The vegetables went into containers, and that day, they were delivered to the Stony Brook Laboratory. So the chain of custody was very tight, and we feel it was very secure. Next. Okay, so we want you to know that now some of you are going to say, well, what farms did you go to? And we're going to tell you that's irrelevant. That is not what this presentation is about. The farmers are not doing anything wrong. We are not blaming farmers and their practices. As Dr. Carla Bennett just said, is that this study is a call for action because it's happening all over America. We had access to Long Island farms, so we tested them. So while this study is alarming, it is not unique to Long Island. It is a broader and a bigger problem that needs to be addressed by the federal government. And now to walk you through the data, we have, and we're very happy to have with us today, Dr. Lokesh Pade, who is the Associate Director of Emerging Contaminants with the Center for Clean Water Technology at Stony Brook University. Turning it over to you.
Thank you, Adrian. So my role here is to introduce the center before I pass it to Kevin to walk through the results. So the New York State Center for Clean Water Technology at Stony Brook University was established over a decade ago to serve the New York State by acting as a research-driven bridge between academia, regulators, industry, and other stakeholders to address the complex water quality challenges, especially on Long Island. As Adrian mentioned, where communities rely here solely on this sole source aquifer. So our work spans the full urban water cycle, linking drinking water, on-site wastewater, and receiving waters. We monitored the contaminants of emerging concerns such as PFAS, tar-derived chemicals, microplastics, pesticides, and pharmaceuticals, study their fate and transport, not only in water and wastewater, but also in some other environmental compartments such as soil, biota, and produce, as in this project. And then we finally developed the cost-effective treatment approaches that can be deployed at scale. So this project is a great example of the kind of community-focused science we aim to deliver. With that, I'm pleased to introduce Kevin Schaefer, Senior Research Support Specialist at the center, who analyzed these samples in our laboratory and will present the findings. Over to you, Kevin.
Thank you very much, Lokesh, and thank you all for being here. Very quickly, before I get into the results that we found for all of these vegetables, I want to just talk very briefly about how we come about these results. First, as Adrian said, we get the fresh produce. It generally goes directly into a frozen state until we're able to process the samples. The frozen vegetable was then shaved and graded down, as we can see here on the left, moving from top to bottom. We have carrots, romaine lettuce, and beets. And those shavings then were put into a dry oven for 72 hours at 50 degrees Celsius. In order to extract any potential PFAS that we might find in these samples, we use potassium hydroxide and acetonitrile. And then to concentrate the sample, in order to analyze it, we use solid phase extraction, or SPE. And then to analyze and quantify the concentrations in the samples, we use liquid chromatography and tandem mass spectrometry, or LCMS. Next slide, please. So we have our results for carrots here, and we can see here the concentrations are all listed in PPT, or parts per trillion. The left of the table, we see the sample number, and along the top, we see all of the different PFAS that we found in these samples and their corresponding concentrations underneath. I will just say here that we see a broad range of concentrations in carrots, and those boxes with the little dash marks indicate that we did not find any of that particular PFAS in that given sample. So again, not all PFAS were found in all samples. Next slide, please.
Well, Kevin, before we go to the next slide, can we just go back one, Jordan? Just for context for people, the layperson watching, the drinking water standard for PFOA and PFOS is 10 PPT. So when you look at the numbers, you can keep that in mind. Also, the EPA has a guidance number. It's old, for food. For PFOS, it's 70, and PFOA, it's 21. So when you look at those numbers, that gives you context. Sorry, Kevin.
Thank you. Okay, so to look at this this same data in a different way, I just first direct you to the y-axis. So that's the vertical axis on the left-hand side of this figure. That's concentration in PPT, and it goes from the bottom 0 to 40,000 PPT. And then along the x-axis, so the horizontal axis at the bottom, we have all of the PFAS that we found in carrots. The boxes represent basically the averages and the full range of samples, the concentrations of samples that we saw in carrots. And the first thing that you might notice or sticks out is PFHXA, which is the blue box, and PFBS, which is the pink box. So both of those concentrations were the highest concentrations that we saw of any compound in carrots, but they fall below the EPA, or Environmental Protection Agency, reference dose. So you ask, what is a reference dose? Well, let's go to the next slide and talk a little bit more about reference dose and look at 4 more compounds that are more important to see here. So the EPA reference dose, it is a means of risk assessment guidance, and it is based on a 70 kilogram or 154 pound person consuming 100 grams or 3.5 ounces of a particular vegetable per day over the course of their life. 3.5 ounces is basically, if we look here on the image on the right-hand side here, we have 3.5 ounces of carrots, of beets, and of lettuce on a normal-sized dinner plate. That's roughly a medium carrot or a medium beet or a decent-sized dinner salad. And as Adrian mentioned, there are reference doses, which we have here for 4 different compounds, and they're listed here on the right-hand side of this figure with corresponding dotted lines that to show where they lie within the concentrations that we saw in carrots. And so we have here first HFPODA, or it's also known as Gen X, with a reference dose of 2100 PPT, PFOS 70 PPT, PFOA 21 PPT, and then PFHXS 0.28 ppt. In carrots, all 4 of those compounds exceeded the daily reference dose. Next slide, please. Okay, so we see here in lettuce, same setup as we saw with carrots. One thing that we might notice is that some of the values the range of values is lower than we saw in carrots. And again, not all PFAS were found in all samples. Next slide, please. So again, on the y-axis here, the concentration, from that vertical axis, we have concentrations of 0 to 3,000. So right away, we can say that in lettuce, we found generally lower concentrations than we saw in carrots. But again, we see that blue box and that pink box, which are PFHXA and PFBS respectively. But again, while those two compounds were the highest concentrations that we saw in lettuce, they still fell below the reference dose concentrations. So if we can go to the next slide, please, we'll look at these 4 compounds of concern here. So we have PFOA in blue, we have PFHXS in pink, and that maroon color is PFOS. All 3 of those compounds were again exceeding the daily reference dose concentrations. However, if we look at that really bright red box, Gen X, that fell well below the reference dose concentration, which we can see the dotted line way up there at 21 ppt. Next slide, please. Okay, and finally we have beets here. Again, the concentrations are lower here, and it should be said that not all PFAS were found in all beet samples. Next slide, please. Okay, so again, looking at that y-axis, the concentration here on the left, from bottom to top, we have 0 to 800. So again, we can say that in beets, we generally saw lower concentrations than we saw in carrots. The other thing to note here is that there are more different PFAS compounds that were of similar concentration across beets, rather than what we saw in lettuce and carrots, where we saw 1 or 2 that were more dominant in higher concentrations. But again, if we can move to the next slide, we look at these 4 compounds of interest here, and we have PFOA, PFHXS, and PFOS again. Those 3 compounds again exceeded the daily reference dose concentrations. And Gen X, in that bright red box, was again below the daily reference dose concentration in beets. Next slide, please. Okay, this is just a quick summary of all of the things that we just discussed in terms of results. If we look at that y-axis again, we have 0 to 1400 ppt. That looks a little bit lower, obviously, than we've seen in carrots, and this is because this is we're looking at averages here of all the samples, where with carrots we had those higher concentrations because we were looking at the full range of concentrations in each sample. So here on the x-axis, that horizontal axis, we have carrots, lettuce, and beets, and then we have PFOA in blue, PFHXS in pink, PFOS in that maroon color, and the bright red is again Gen X, respectively, for each vegetable. The first thing that I think that might jump out to everyone is that PFOS and Gen X in carrots was considerably higher than we saw in any of the other vegetables. The other thing I would say is that, generally speaking, there wasn't a lot of variation or in PFOA or PFHXS in all 3 vegetables. They're all the concentrations that we saw were very much in the same ballpark. That's it for me. Thank you.
Thank you very much, Kevin. We appreciate it. Our next speaker I'd like to introduce is to tell you why we think this is happening, although more research is absolutely needed. I'd like to introduce Dr. Lakesh. No, I'm so sorry. Dr. Stephen Lassay, who's an environmental toxicologist with Lassay Research Consulting. Stephen?
Hello, everybody. So the first question to ask is, how do these concentrations we found really compare to what's out there? Well, they were quite a bit lower than vegetables that are grown in soils that are industrially impacted by biosolids in the United States. They were, curiously enough, pretty similar to vegetables that were grown near a fluorochemical plant in the Netherlands. And they were higher than random sampling from supermarkets in Australia with no known contamination source. Also, at this point, we have no known contamination source for the results we found. Next slide. But how do PFAS actually end up in vegetables? Well, vegetables and plants in general have 4 intake routes, right? They have whatever's in the soil they're grown in, they have whatever's in the water that they take up, whatever's in the air, and then sunlight. And well, sunlight should not be a source of PFAS, but the other 3 could possibly be. Next slide. First, we can talk about what biosolids are. Biosolids, as Kyla had mentioned before, are the leftovers after waste treatment facilities. Instead of being the water, they're the solids. And these can come in different forms, but the EPA has 2 classifications for them. One is Class A, and it meets a strict ceiling and cumulative pollutant limits, none of which at this point include PFAS. So they're not regulated for PFAS. And they can have unrestricted use. They can be sold in bags in retail. They're used on home lawns and gardens, public parks, etc. Next are Class B. It has the same pollutant limits as Class A, but they're less restrictive, again, not including PFAS. And they do, as a result, have restricted use. Site access and crop harvesting restrictions are there. They're applied to farms. I don't know if this is the case here, but and they cannot be bagged and sold to the public. They're mostly applied bulk to agricultural lands, forest, and reclamation sites. All right, next slide. What does a Class A biosolid look like? Well, here's 2 pictures of a Class A biosolid. And they are clearly labeled on the back of the package, sometimes less clear than others, that they're derived from biosolids. Next slide. This is more what a Class B biosolid would look like, something that's being applied to an agricultural field. They can also look more similar to something like sewage sludge, so liquid. All right, next slide. So as I had mentioned earlier, water can be the source of PFAS pollution. And as Adrian had went over before, there is some water contamination on Long Island. But at this point in the project, we have not really looked that far into that. Hopefully something in the future, but it is a potential source. We don't know yet. Next slide. Applied products can also be a source. So things like pesticides and fertilizers and other things that might be applied to harvested vegetables. We regulate pesticides off of their degradation rate. Well, if there are PFAS in pesticides, they don't degrade. So while the pesticide may diminish, the PFAS that are maybe in those pesticides do not. All right, next slide. And wet and dry deposition. I wanted to point out this because, as I had said earlier, air is the potential source. And oddly enough, the concentrations we found here were most similar to concentrations seen near a fluorochemical plant in the Netherlands. We have no information really connecting these 2, but it is a potential source. And what wet and dry deposition look like is dust from the air, whatever might fall out of the sky, and then also rain. Next slide. Lastly, it's a good thing to point, biomagnification happens with PFAS. As Kyla had said earlier, it's found in meat, right? And in the case, we didn't test, grasses or other fodders in this case, but they take up PFAS just like any other plant, and actually quite readily, and cows can eat up to 20 kilograms of feed a day. So you can get large concentrations of PFAS in meat as a result of their consumption of contaminated plant material. And that's it for me.
Thank you very much. So I want everyone to know, as we said earlier, this is not a farming problem. This is a societal problem. And while this study is very concerning, it is not unique to Long Island. And we believe this is a national or global problem. We wanted you to know the New York State DEC did study soil in rural communities throughout the state of New York in 2023. They actually did 548 soil samples. They collected that at over 116 different properties. And these were properties very remote, where no reason to believe that PFAS would be found in the soil. And yet, PFAS was found in the soil. 97% of surface water samples had some level of PFOS, and 76% had some level of PFOA. And then other PFAS chemicals were also detected. So the conclusion of that study is that PFAS contamination is pervasive, and there are multiple pathways by which this chemical is getting into our food system and our water system and our soil. And please keep in mind, one of the things that is significant, I think, with growing fruits and vegetables is that the vegetables and the fruits are bioconcentrating or bioaccumulation of these toxic chemicals. So if it's coming through water and soil and a fertilizer and a pesticide, it's all being taken up by the root system and entering into that vegetable collectively. As Dr. Bennett said, these chemicals are very persistent. That's why they're called the forever chemical. They do not break down. And what happens is they end up in concentrated form in whatever is absorbing them. Cows, things at the top of the food chain, but also, as we can see from this study, vegetables. Again, I can't say this enough. We are not blaming the farmers. We need federal action on this. Turning it back over to Kyla. This is me. I'm so sorry. Okay, turning it back to myself. So one of the things we need to do is stop PFAS at the source. For instance, right now, there is a very critically important bill that would stop PFAS from being used in common everyday products, like things like your clothing, your textiles, rugs, cookware. People in New York are not waking up in the morning and saying, you know what I want with my scrambled eggs? I'd love a side of PFAS. And yet, that's what we're getting. So we need to ban it from our cookware and from these common household products. The bill, we're delighted to tell you, has passed the Senate last month, flew through, and we thank the New York State Senate for that. The Assembly is where it got stuck last year. We need the Assembly to move on this bill. It doesn't make any sense to keep taking the PFAS out of our drinking water, worrying about it getting into our soil, if we keep adding it into these products and adding it into our bodies, into our environment each and every day. So this is a very important bill. It's Assembly Bill 7738A. We need the Assembly to get it done. Next slide. We're not going to go through this in the interest of time. Just keep going. Kyla.
Thanks, Adrienne. So what do? we do not want to scare you away from eating vegetables. Vegetables are super important for everybody to eat. So it's all about minimizing your risk. And when you're talking about a chemical for which there is no safe level, like PFOA, PFOS, lead, arsenic, reducing any exposure will always reduce your risk. So where can you reduce your exposure without giving up eating? Because we need to eat to survive. First of all, I do have to say that vegan diets, there is evidence that eating vegan may be related to lower PFAS levels in your blood. And about 98% of Americans have PFAS in their blood. It's a lot. That's how ubiquitous this is. But if you eat lower on the food chain, you don't deal with that biomagnification problem that Steve talked about. And so vegans tend to have less PFAS in their blood because it builds up as you go up the food chain. But what else you can do is get a water filter for your house to make sure that your water is as clean as it can be. My town has a municipal water filter, which cost us $11.2 million, but I also have an under the sink filter in my kitchen. I use it for making coffee and tea and giving my dogs and making ice and absolutely everything. I also have filters for my shower because remember, PFAS can be dermally absorbed. So you can minimize your risk that way. Also, check your consumer products. You don't need nonstick pans that are covered with PFAS. You don't need makeup or shampoo that has PFAS in it. There is a great website that's been put out by Green Science Policy Institute called pfascentral.org that lists a number of products that are PFAS free. So you can look for alternatives. Now, I hate to shift the burden of protecting yourself to you, but that's where we are right now. This should be an EPA issue. EPA should define PFAS broadly. Right now, they have a fairly narrow definition, which is different than state definition of PFAS. So they should define it broadly. They should regulate PFAS as a large family of chemicals instead of this whack-a-mole individual chemical by chemical regulation. And they should ban all non-essential uses of PFAS. And when I'm talking about non-essential uses, I'm talking about makeup, pans, artificial turf, carpets, even rain gear. You can get waterproof rain gear that doesn't have PFAS in it.
Dental floss. That's my favorite. People don't know it's a dental floss.
Yep. So, and then they can start working on what I would consider essential uses, medical devices, medicines. There are a lot of pharmaceuticals that are themselves PFAS. For example, Prozac, Flonase, the allergy medicine, and Paxlovid, the drug that they give to you when you have COVID. So those are more essential, but we absolutely do not need it in the vast majority of our consumer products. So what you can do, don't stop eating vegetables. Don't blame the farmers. There's nowhere you can escape this at this point. So putting pressure on EPA is one of the best things we can do. Pure is currently suing EPA over its failure to regulate PFAS in their biosolids. But on Long Island, it does not appear that the farms use biosolids. Some of them may use bagged fertilizer. We don't know, but they don't seem to use biosolids. So it's probably, the source on Long Island is probably coming from somewhere else. So try to minimize your risk elsewhere. Keep eating your vegetables. And we are going to continue this research and try to figure out where this might be coming from. Thank you for listening to us all.
Okay, great. We have a lot of questions going on, so we're going to do some in rapid fire. Is the panel ready? Okay. Jean, has a question. Can you please provide some context around the high numbers for PFHXA in the samples, which had low numbers for PFOS, which is worse? Do they have the same effects on the human body?
Yeah, I can take that question. So I think those two are different PFAS, of course, as you know. The PFAS is more a legacy PFAS, and PFHXA is a lower carbon. I would say probably something whose concentrations are rising because of the replacement PFAS, which probably break down into this C6 PFHXA, carboxylic acid PFAS. PFAS has been studied much longer. It's more bioaccumulative, has longer half-life in our body, so appears more concerning. But I just want to make a note that PFHXA is less studied, lot less studied. So there are a lot more uncertainties about its health impact. That said, though, the numbers are not very surprising because if you think about PFHXA, it's more mobile and it's more soluble in water. So the plant uptake will be higher. That does not necessarily mean it's more concerning, though. So just distinguishing the numbers from those of toxic effect is really critical here.
Well, I want to just have it like a little bit of a different. I was shocked by the numbers. I want to be perfectly clear here. Jordan, can you go back to maybe those carrot numbers and bring up that slide again? I think for context here, to see that I was not expecting that. I don't know, Dr. Bennett, if you were expecting these high numbers, but there has to be more research done. This was a small study. This was meant to be a sample to see if there was something going on, to see if we had concerns. But when I look and see a carrot had 950 parts per trillion of PFOS, I'm concerned. When I see that there's, 100 and even 130 in a carrot, and as we said earlier, one normal sample for a 150-pound man, well, I'm not 150 pounds. So my sample that I should be exposed to is much less than a few carrots, right? It's probably 2 baby carrots. I don't know what it is. So these numbers are concerning to me. Can you go to the next one, Jordan? I think it's keep going. The lettuce. Okay. And you can see here, 180. That's a lot when you start looking at the combination of numbers and the quantity of consumption in this food. So we were surprised, and we find this again alarming, but I want to stress this is not a Long Island problem. This is a United States problem. Okay, let me go to the next question real quick here. I know you can't share the exact location of farms you tested. That's correct. We're not sharing that. But can you speak more about the variety of locations? Well, just going to say, no, they were not near each other. That's a good question. They were on the North and South Fork of Long Island. And that's all we're going to say. Okay. Eric Goldstein, excellent presentation. Thank you to all the experts. Was there a significant difference between PFAS found in organic versus non-organic farms? Okay, let me answer this. We only did 2 organic farms. No, there was not any difference at all. Some were higher in some vegetables, some were lower in some vegetables. And this is why it also compels us to say this is not about farming practices. This is not about farmers. This particular chemical is very insidious. It has become ubiquitous in our environment. And it is not as a result of practices being conducted by farmers.
Adrienne, can I hop on? Can I say something, add something to that? There is some scientific literature that suggests that organic farms, the vegetables there have less PFAS than conventional farms. Conventional farms can use synthetic pesticides and can use biosolids. Organic farms are not allowed to. However, it is not the rule, as we found here. And I saw a study done that some organic kale had massive numbers from not on Long Island, someplace else. So we can't always tell because we don't know where the sources are from. Clearly, when you're using biosolids or pesticides that have PFAS, you're going to have higher PFAS in the vegetables. But for so many of these, we just have no idea where the PFAS is coming from. So organic versus conventional right now, it's a toss-up. In certain areas, there may be a difference, and in other areas, there may not.
Okay. What levels of PFAS are you finding in vegetables brought from the supermarket? We did not test it. What we did was, that'll be next. That'll be our next project. It's a great question. We would love to do that comparison also. My guess it's going to be more at the supermarket because they love to cover them in plastic. But I don't know that. And I don't want to give out information that we don't have scientific data on. So we did not test supermarket food. But supermarkets get them from farms, except they wrap them in plastic first. These were vegetables not wrapped in plastic. Actually, I should say that. They were all purchased at the farm stand at the farm. And yes, this person's saying we need to support our local farms. We couldn't agree more. We agree 100%. This is from WSHU Radio. Is there data from New York State at large or nationwide that you can compare the Long Island numbers to? In other words, how does Long Island produce compare to California farms or upstate New York? Kyla? Steve?
I can say not really. That's really the answer, is there isn't really comparable data to compare it to.
Why was Long Island Farms chosen for this investigation? Well, because this is where our office is, and we went to Long Island Farms. We're not picking on Long Island. We love Long Island. We support our Long Island farms. Again, the message here is not that it's a Long Island problem. The message here is that this is a national problem. The other few studies that exist, whether it's in Sydney, Australia, Denmark, or California, they have this problem too. We just had not seen any recent studies here in America, or specifically in New York, and we launched this one. You always need more data into the scientific realm. First, we have to identify the problem, and then we can solve the problem. Okay. Could the high levels of carrots be due to soil adherence to the skin of the carrot? Were the samples washed and peeled? Were the chemicals found in high numbers less likely to move in water?
Kevin, you want to answer this?
Yeah, I think that's Kevin. Kevin went through how that was done, but Kevin, can you just say it again for Sandy, please?
Certainly. So I did not personally wash the vegetables. I will say that given that they came from a farm stand, they were not covered in soil, and so they were relatively clean. I processed them from a frozen state, so they came in looking like carrots that you would get in a store. I froze them, and then I grated them down to shreds with a microplane, really, and then process them from there. So that's how we process it. So the idea that it could potentially come from an excess of soil on the outside of the vegetable is not likely, I would say.
Yeah, not at these levels.
Yeah,
that would be another whole problem. Okay.
Yeah. And for the peeling question, sorry, there's some studies that find that peeling can reduce the amount of PFAS, but in the end, it's going to be throughout the carrot. Realistically,
it's systemic.
Yeah.
Okay, Jean is asking, is there anything you can do to the vegetable, like cooking at high temperatures or microwaving? Did that make a difference in eating them? Kyla, I see you shaking your head.
No.
Yeah, no. PFAS are known for their chemical stability. There's nothing you can do to break them down. That's why they're called the forever chemicals. That, on the other hand, if you happen to have an oven that goes up to 2000 degrees Celsius, you might be able to do it.
Right. I was just going to say, even incinerating PFAS, it still comes out in the smokestack. It's very, very difficult to break those bonds. So yes, cooking the vegetables is not going to make a difference.
We're depressing the over 100 people that are on this. I'm sorry about that. Derek is asking, do you know that this produce actually came from that farm stand? Well, it was a farm stand at a farm. You're saying here, sometimes they will sell from other places. That's true. Again, since we're not blaming individual farms, that's not essentially relevant to this report. What we're talking about is the amount of these toxics that are being found in these particular vegetables. Okay. Let me just see what else we have here. Okay, I think that we've run through most. I'm sorry if I missed any. I tried to go through them really quick. I don't know this is a question from Christine. What were the positive and negative controls for the PFAS? This would be helpful to know for future experiments. I don't know. One of the scientists, can you take that, please?
Sure. Our positive controls, our spikes were, all the samples were spiked with 10 microliters of 100 ppt. The samples were of surrogate. Then the samples were corrected. So the values that we see here were corrected for the presence of the surrogates in each sample. And additionally, we had system blanks. And also solvent blanks, so lab fortified blanks. So those are basically the same solvents that potassium hydroxide and that acetonitrile that we use to extract the PFAS from the samples. We use those as system blanks. One was spiked with the similar surrogates that we used in the actual matrix samples, and then the others were the system blanks would be just the solvent to see if anything from our system, the system itself, is getting into those solvents and into our samples to contaminate.
And in general, I will say from experience, it is financially unviable to try to find food products for controls because it's so difficult to find them in general. So you can go out there and test a food product to be your control, and you'll find out it has PFAS in it, and therefore it doesn't work. And then you can do that for a year and decide, maybe I can't find a control.
All right, we're going to have just two last questions, and we're going to give one of the last ones to, oh God, I just lost it. I'm so sorry. Well, one is to Edwin. Follow-up question. Are there any regulations on PFAS in food being considered by New York State lawmakers? I can answer that, no. And what might regulations look like? That is a much longer discussion, actually, Edwin. This is a complex issue. And, earlier, I think it was you asked the question, that there are federal standards. There are not really federal standards. There are guidelines. And Carla, can you speak about the difference between a guideline and a standard? There are no federal standards and there are no state standards, but there are guidelines. Carla?
Sure. So EPA has issued health advisories and guidance, which are not enforceable. They did finally, again, in April of 2024, issue some regulations which are enforceable under the Safe Drinking Water Act for 6 different PFAS in drinking water. However, the Trump administration has delayed implementation of those, so they are not actually in effect and will not go into effect until 2031. The states do have, like New York does have drinking water standards, but I don't know of any states that have enforceable regulations regarding the amount of PFAS in food items. There are some do not eat advisories, again, not enforceable on certain things like deer meat or fish taken from certain streams or certain areas, forests that might be near, for example, a Department of Defense base. But again, there are no enforceable regulations regarding food in the entire United States. One thing, I think I saw somebody ask a question about where they get a good filter. My recommendation is to go to NSF, the National Sanitation Foundation website, and search for filters that take out PFAS. The NSF is a third-party certifying organization. They're good, and they test all of the claims, and they have a list of filters that that you can use that they know will take PFAS out. I would not just go by manufacturer claims, but rather go to a third-party certifier to make sure that you're getting something that works.
Okay, the last question we're going to have, and then there's press that want to ask you guys questions also that are here in person. But from the Zoom here, to the scientists, they said they knew, I said I was surprised at the results, but are the scientists surprised at the results?
Yeah, I would say, sorry.
Yeah, go ahead, Lokesh.
Yeah, go ahead.
I think, not to the extent probably Adrian was surprised. I think some of the, especially the shorter chain PFAS levels, now we are seeing it in different environmental media, and those levels are rising as the years are going by, because a lot of these long chain PFAS precursors actually break down into something like PFHXA. And there were a couple of questions about that, this short chain PFAS, why we are seeing these higher levels, and does that mean they actually move through the water and more toxic and things like that. So the short answer is that some of these concentrations were expected. If you look around what we expect from different media, what will be in the food produce. That said, though, just seeing those numbers overall is still alarming for us to some levels. Steve.
I would echo what Lakesh said. Many of the numbers are not surprising, but some of them are quite surprising.
Yeah, I agree. And the one thing that surprised me is I've done a lot of testing on fish and calf liver and lobster and things like that. In those, I expect, especially things like lobster, which are bottom feeders, I expect to see very high levels. I was surprised to see some of the levels in vegetables. I was. Again, not unique to Long Island, not unique to the United States of America. This is a global issue. I saw somebody sent me some results of potatoes from the UK, and it was horrifying levels. So it's everywhere.
I had saw a question earlier, somebody asking if the concern about PFAS in meat was inherent to the meat. And there was no PFAS in meat before PFAS were invented, right? It's completely anthropogenic chemical. If you have animals, fish, whatever that are raised off of land or water that is not contaminated with PFAS, you shouldn't expect any PFAS to be in them. That being said, there's a lot of PFAS contamination.
Okay, so thank you, everybody. I'm sorry if this was a little depressing, but let me say this. We are working on regulations. New York State has a great drinking water regulation, one of the strictest in the nation. We are working on passing bills right now as we speak in Albany to reduce PFAS, and we're going to keep doing it. We're going to continue on with the research, but we're going to continue on with the activism as well. So thank you for logging on and learning.